Hi, hello everyone. Today we will focus on the third part, that is the last part of our topic, that is the aromatic acids. Last we have done the two things, that is aromatic amine and the phenol. Today we will start off with the aromatic acids. The aromatic acids. The term acids can be signified with the term as COOH. That is a C double bond O and the H. If it is being directly attached with a benzene ring, we call it to be as an aromatic acid. So the compound in which one or more carboxyl groups are attached directly to the aromatic ring, we call it to be as an aromatic acids. So concentrate on the first one as a benzoic acid. Then the second one 2-hydroxy or ortho-hydroxy benzoic acid. Then we concentrate on the 2-amino or ortho-amino benzoic acid. When correspondingly two carboxylic group are being attached together, we called it as phthalic acid. Moreover, if a methyl group is being attached, we call this as to be as 2-methyl or ortho-methyl benzoic acid or toluic acid. Similarly, case of the nitro group is being attached, we called 3-nitro-benzoic acid. Now, concentrate on the acidity. So here comes the important part of the aromatic acids, which we will focus today on this part of the video, is the aromatic acids. The aromatic acids basically the acidity of the aromatic acid is our point of interest. So the pi electron plays a major role in the acidity of the carboxylic acid. The negative charge of the carboxylate ion is being shared between the two carboxylate oxygen atoms and cannot be effectively delocalized by the aromatic ring. Hence, the acidity is basically influenced by the inductive effect. So, moreover, we can a bit simplify it, that we will take the case of phenol and the case of aromatic acid. We have learned that in case of the phenol, we form the phenoxide ion, for which it gives an acidity, and corresponding the aromatic acid, it will form a carboxylate ion when dissolved in water. We will focus on the second part of the video of this one to know the acidity of aromatic acid when comparison with that of the phenol. In continuation to the first part of the video, here we will concentrate on the acidity of the aromatic acid with that of the phenol with any other compound. So let's take a aromatic acid. So it is a COOH. COOH, when we dissolve it in water, it will form a carboxylate ion. Carboxylate ion is nothing but COO minus plus H3O plus. Similarly, we can see that if you just recall in case of the phenol, we have seen that it develops a phenoxide ion. The phenoxide ion almost looked like this one. Phenoxide ion, it is being produced in case of the phenol, and moreover it takes part in the delocalization, the development of the negative charge of here, this part and this part, which plays a major role in the acidity of the phenol, and is being producing a resonating structure with the benzene ring to get being stabilized. And moreover, the stability of any compound will be depend upon the oxygen. Here we will take into account the oxygen, where a negative charge has been developed. To get it neutralized, it will again revert back the hydrogen ion to get it stable, and correspondingly the negative charge which being basically developed is being basically developed in this position, and that position of the carbon atom. Now let us focus on the resonating structure of that of the carboxylic acid. So the carboxylic acid basically takes place in this form after resonating the C double bond OH, C double bond O, and correspondingly the OH. So let's just delete this one. So if we dissolve in water, this hydrogen will comes on the ship to form a H3O plus. So hence there will be developed a correspondingly negative charge here. Correspondingly negative charge will develop here, and correspondingly this will produce and shows the acidity. Hence we will take the resonating structure of it. So again we take the resonating structure of it to be as CO correspondingly O. This is our main structure. So here it will, the O minus will shift here, and correspondingly this bond will goes to the oxygen. Hence the compound we will get that C double bond O and CO minus, and correspondingly a phenyl group. Now we can see that in the total process of the reaction, it does not involve the phenyl ring anything with the resonating structure. It has been forming the two resonating structure within the carboxylate ion only, that is in this position and in this position. The carboxylate ion are being basically responsible for the total resonating structure, doesn't being involved with the phenyl group. Now just clear it. In case of the phenol, we see that the resonating structures are being involving with the phenyl group. But in case of the carboxylate means the aromatic acid, the negative charge are being basically developed over the two oxygen. That is, if we see very carefully, there is a oxygen, this two, a partial negative charge develops here and a partial negative charge develops here, and the electron cloud density is basically rotates over this position. Hence we can see that the tendency to revert back the hydrogen ion in any water solution is very less in that of the phenol. Hence the benzoic acid we can say is more acidic than phenol, and moreover the total effect is being incorporated by the inductive effect, and moreover it is directly not being associated with the pi bond is directly not being associated with the benzene ring, but in case of the phenol we can see that entirely associated with the benzene ring. So from there we can conclude that benzoic acid or aromatic acid is more acidic than phenol, and the total acidity is basically depends upon the resonating structure of the two resonating structure, which the negative charge basically develops over the oxygen. Thank you.